Welcome back to Education Program Online with me, Teacher Christine, taking you in mathematics for Senior 4 and Senior 3. So learners, our topic remains real functions and limits. The previous lesson that we had, we are looking at graphing a function. And under graphing a function, we looked at the two relationship, that is a relationship between the linear functions and nonlinear functions. And we are able to see the examples on linear functions and examples on nonlinear functions, especially on quadratic graphs. So now we are going to continue on the same part of graphing a function. Graphing a function. Graphing a function. So we are still continuing on this part of a function. But what are we going to look at now? Specific, we are going to look at how do we prove that the given equation is a function or is not a function. Because not all the equations are qualified to be called functions, or meaning, of course, we know what a function is as a relationship between the two variables. So we want to see how do we prove that the two variables are related. How do we prove the two variables are related? So I want you to write this down. You say determining whether or not the given function, the given equation is a function. The given equation is a function. So this is what we are going to look at, and we shall see how do I really determine that the equation that is given, is it a function or is not a function. Looking at back our equations that we looked at, that is the linear equations and the quadratic equations. So from those two types of equations is where we shall see whether the equation given is a function or not a function. So let us look at example. Example 1. Example 1, they say determine whether or not a given function is the given equation below, the given equations are functions. So, and then they say part A, we have x square plus y square equals to 1. And then part B, we have y cube plus 3y plus 2x equals to 0. Equals to 0. So, learners, in a situation where you are given this kind of questions, looking at question part A. Question part A, we find this kind of questions in what we call equation of a circle. It is under equation of a circle that we find this kind of equation. So, they will ask you to determine whether question A is really a function or not a function. So, how do you do, or what do you do in determining this? What you do is you are to look at it, that if I'm to get there to prove this, then the x which is the domain, which is the domain, we substitute it with 0. We assume that x is 0. So if x is 0, what will be the outcome of the relation of this given equation? And then after that, then you will be able to determine if it is giving us one variable, then we say the relation is true. If it is giving more than that, then it means the relation is not true. Because always relation, the true relation is always between the two items. Now, if it goes beyond the two items, then it becomes undefined. So, let us go to the solution of this. So, our solution for part A, we say x squared plus y squared equals to 1. And therefore, let x be what? Let x be 0. So, if x is 0, then we shall have x squared plus y squared equals to 1. And therefore, this will be 0 squared plus y squared equals to 1. And therefore, this 0 will go off, and then we remain with the positive y squared equals to what? Equals to 1. So, for us to get that the relation is true, then we have to specifically look at the two variables, that is x and y. Therefore, here they have given us y squared. We need to get the y alone. And therefore, for us to get the y alone, then we have to root both sides. So, you root both sides, you root the y squared, and then we say equals to plus or minus the root of 1 equals to 1 plus or minus the root of 1. Why do we say plus or minus? Because when you look at the y square, the outcome may be positive or negative. So one of the roots may be positive or one of the root may be negative. So this is symbol here of the square root will cancel with our power 2. And then you remain with the y equals to plus or minus a root of 1. And then now when we look at the root of 1, we simply now say if y equals to the root of this, we can split it by now having y alone can be positive negative 1, or y alone can be positive 1. We are there. So when we split this, it gives us, assuming we have ignored the root, the symbol of the root, because the roots are already telling us that y can be positive or y can be negative. So what do? We simply look at now y alone as being negative 1 or y alone equals to positive 1. So when you look at this, you will find that is this relation, is this outcome telling us that the function is the equation A is a function or not. So we simply find that in our introduction of functions, we said x being a 0, it means it is undefined. It is undefined. Therefore, if it is undefined, then the two outcome, the two output will not satisfy the equation A to be a function. So the answer is the equation is not a function. The equation is not a function. Why? Simply because x being substituted by 0 gives no meaning in the relationship. So in your conclusion, you say, therefore, since there are two values of x equals to 0, two values of y, when x equals to 0, when x equals to 0, when x equals to 0, hence x square plus y square equals to 1 is not a function. Is not a function. So that is your proof. Flashing back, I don't want you to get confused on this part here. That how do I know that it is not a function? We know that a function is the relation between the two variables, that is x and y. But now when you look at here, you find that all the outcome are for y, meaning that the two variables are all y, and therefore how can y be a friend of y again? Therefore, this simply tells us that there is no relation that can occur within only you yourself. Only you yourself. This is what it means. The relation within you yourself. But it cannot happen. Then you simply say it is not a function. But in case you find that maybe y is carrying something different and x is also carrying something, that there are two variables of different kind, then we say the function, the equation is a function. So let us move to part B. So part B says y cubed part B, it says y cubed plus 3y plus 2x equals to 0. Prove whether the given equation is a function. I always say that if you want to prove whether the relation is 100%, you try to lower yourself to 0. Assuming you have told your colleague that I have 0 money in the pocket, and then I want our relation to continue. You will discover the truth, whether that relation will continue when you have 0. So that's why we always see, for you to approve whether the relation is good or is bad, or the relation is true, is for you to lower yourself to the 0 point. And then there you will discover whether that person really likes you or he doesn't like you. So for us to prove whether the equation is a function, we equate x to 0. That is, mathematically we equate x to 0. We say let x be 0. Just like the way you say you lower yourself. If you have a friend, you lower yourself that I'm now totally poor, 0. I don't have any money. And then your friend has money. You will see that your friend will dodge you and leaves you. The relation will break off because of that. So mathematically we equate x to 0. And if we equate x to 0, let us see what will happen. We say y cube plus 3y plus 2 times 0 equals to 0. So this will give us y cube plus 3y equals to 0. So now you can find that you are left with only the same variable. That is y cube plus 3y. So we are to simplify this until we get the value of y alone. And now when you look at this, you find it is the power is more than 1. Now what do? You simply factorize. We cannot root. We only root if the power is 2. But if it is beyond 2, then we have to break it by factorizing it. So let us factorize this. So when we factorize this, what will it give us? We shall get y into y square plus 3. So when we factorize this, we get the common factor to be y. Because when we multiply y times y, it will bring us back to y cube. And then when we multiply y times 3, it will give us 3y. Now, to this level, we are going to quit y. Because y is outside the bracket, we quit it to 0. So we simply say y, in this case, equals to 0. And then we have y square plus 3 equals to 0. So y square plus 3, it means we have to simplify for y. And how do we simplify? We eliminate first the constant from here, and then we shall have y square plus 3 minus 3 equals to 0 minus 3. Such that this 3 will automatically be cancelled from your left side. And then you remain with the y square equals to negative 3. And we said that any number, any variable which is in a square form, for you to get the variable alone, you have to root both sides. So we square root, we root the y square, and then it gives us, we expect the two roots, that is positive or negative root of what? Root of negative 3. So this symbol here will cancel with the power, and then we remain with the y equals to plus or minus a root of negative 3. So the root of negative 3 will definitely give us now y equals to, when we split this, we simply get y equals to 0. So you simply say, I will have y, our first y here is 0, comma, and then we say y is equals to negative 3, and then we also have y equals to positive 3. So those will be your output. Now, since it is on roots, you say this is root negative and then this is root positive. What happened here, you will find that this automatically from here, it tells us the function, the equation is not a function. Why? When you go deeper, we find that the outcome here, which is a root of negative 3, it means a root of any negative is not a real part of a number. And since it is not a real part of a number, it means the equation does not satisfy or does not qualify to be a function of a function. So then now you simply say, therefore, y is not defined at x equals to that, since y equals the root of negative 3. Just because of this, it disqualifies the equation to be a function. So you say y is not defined at x equals to 0. At x equals to 0. Since y equals to a root of negative 3, which is not a real number, y cube plus 3y plus 2x equals to 0 is not a function. Is not a function. So dear learners, this is how you prove whether any given equation is a function or is not a function. And we have dwelt so much on proving when the equation is not a function. As I conclude, I say, looking at the outcome, for you to prove whether the equation is a function, you lower the x to 0. You quit x to 0. Just as I told you that even in everyday relationship becomes good when both of you have. But a situation where one does not have, automatically that relationship will cut off. So mathematically, the relation becomes true if both variables are having real numbers. That is x having a real and y having a real. Then we can say the equation is a function. But a situation where you find, in case of this, a negative roots are not considered to be real number. When you look at complex number, we have real parts of a number and imaginary part of a number. Because even if I ask you now that, class, what does a root of negative 3 mean? You will all look up, meaning that you don't have a defined answer. But if I say, what is the root of 4? Because it is defined, you will automatically tell me the answer is 2. So, because of this negative root, it disqualifies the equation to be a function. So, let us look at it. Sometimes they will ask you, present this on a graph. Present this on a graph. So we can treat it as example number 3 or party example number 2. So example 2, they will say draw example number 2, show on a graph whether or not the given equation is a function. Show on a graph. Show on a graph whether or not the given equation is a function. And the question is x squared plus y squared equals to 25. Equals to 25. So 25. So assuming you are given this question and they want you to represent this equation on your graph, what do? First, before you go to your graph, you identify that these are equations of a circle. So you get the solution, and here they are mentioned whether it is a function. For you to prove whether it is a function, then you equate x to what? To 0. You equate x to 0, and then now you come and say x squared plus y squared equals to 25. And if x is 0, then I will have 0 squared plus y squared equals to 25. Equals to 25. That means we have y squared equals to 25. And we said if it is a square, then we root both sides. So when we root both sides, we get y squared equals to plus or minus 25, a root of 25. So y alone will give us plus or minus 5. Plus or minus 5, which we simply say y can be negative 5 or y can be positive 5. So from here, we automatically see that the relation is basing only within itself, and therefore it is not a relation. It is not a true function. So that equation is not a function, and therefore if we are asked to represent it on the graph, then you will have our graph. This is y and this is x-axis. So we shall have our graph of this kind. So we have our graph of this kind. So learners, we take that one to be our graph, and if we are to plot it, you look at this. We look at it on the y-axis. We find that we have negative 5 and positive 5. So you show it on your graph here. We say this is our 0, and then this is 1, 2, 3, 4, 5. So we say this is positive 5. And then we have this is our positive 5. This is our starting point 0. Here we have negative 1, negative 2, 3, 4, negative 5. So this is negative 5. And then when we come downwards, we have negative 1, 2, 3, 4, 5. So this is negative 5. And then upwards, we have positive 1, 2, 3, 4, 5. So learners, that is how you can plot this kind of a graph. You only look at the outcome, the values of y, and then you place them in your graph. And then now you join them. So you join them in this form. Your line should pass through those points. Of course, this one is not very accurate, but I think you have got the skills. So it goes through the points of 5. So that is what we call a graph, not a graph function. Graph, not a graph function. So that is how you represent it on your graph. You'll plot what the outcomes of y, and then you show them on your graph. And then now we have come to the end of our lesson. But before we close up, I want you to take these 2 questions. You go and try in your free time. Determine, this is exercise homework. Determine whether or not the following equations. The following equations are functions. You say A, you have y equals to x cubed plus x squared plus 3x plus 4. And then B, we have y equals to x cubed minus x. And C, which is our last, is 3x squared minus 2y squared plus 3xy equals to 0. So, dear learners, with this, we have come to the end of our lesson, and I hope that you have picked something from these examples on how to determine the given equation to be a function or not. With this, I say goodbye for today.